Welcome back to my YouTube channel. Today I will solve a question of a JAM exams. Okay, question is given that A is a matrix. Okay, and consider the linear map TA. Okay, linear maps or linear operator TA on the vector space M4R, that is collection of all 4 cross 4 matrix which enters from the R. Okay, and defined by TAX equal to AX minus XA. Okay, for all x belongs to M4R. Okay, now given here TAX equal to AX minus XA. Okay, for all x belongs to M4R. Okay, now in generals this is matrix A equal to given 1 0 0 0 0 1 0 0 0 0 minus 1 0 0 0 0 minus 1. Okay, suppose x is in generally A B C D E F G H I J K L M N O P. Okay, this matrix. Okay, and this is minus A B C D E F G H I J K L M N O P. Okay, and here 1 0 0 0 0 1 0 0 0 0 minus 1 0 and here 0 0 0 minus 1. Okay, now first we product. So first we multiply those matrix, so we can find this is equal to 1, this is equal to A. Okay, here B, here C, here D. Okay, and here E F G H. Okay, and here minus I, minus J, minus K, minus L. Okay, and here minus M, minus N, minus O, minus P. Okay, and minus here A. Okay, A 0, A B. Okay, minus C and minus D here. Okay, and here E F. Okay, minus G, minus H. Okay, and here I J minus K minus L. Okay, and here M N minus O and minus P. Okay, so we have this equal to 0 and this is also 0 and this is 2C and 2D. Okay, and here 0 0 and here also 2G 2H. Okay, and here minus 2I minus 2J. Okay, and here 0 and here 0 also 0. Okay, and here minus 2M minus 2N. Okay, and here 0 and also here 0. Okay, so finally we have T of TAX. X here A B C D E F G H I J K L M N O P. Okay, this equal to this map. Okay, and we already know that the range, if e1 e2 dot 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 en is a basis of v, where t is a linear operator from v to v, then range space of t span by t of e1, t of e2 dot dot t of en. Okay, span this set. Okay, we can find first of all this value. Okay, then we find which set is formed as Li set. Then we can find basis of the range space and then also dimension of the range space. Okay, now first t of one others all zero entities. Okay, so this equal to 0, all 0. Okay, and where we easily see that when b equal to 1 other zeros, then for all zeros, when here non-zero entities for c and d, and here I and j and g and h and m and n. Okay, others all are zeros, but here non-zeros. So all zeros for t of 0 0, c, where is c? Here c. If c equal to 1 and 0 and others 0, then this value equal to, we have 0 0 0 2 0, all are zeros. Okay, and similarly when here non-zero 0 0 1 0, 0 and here 1 and others all zeros, then here 0 0 0 2, all zeros. Okay, and similarly we can find when here 1 basis element, here 1, then here 2, all are zeros, and similarly this. So clearly the span this set, range of t span by this set 0 and 0 0 2 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay, and here 0 0 0 2 0 0 0 0, all are zeros. Okay, and also here also. Okay, and also this set 0 0 2 0 0 0 0 2 0, all are zeros. Okay, and similarly 0 0 0 0 0 0 0 2, all zeros. Okay, and also here and here this place are non-zeros. So this set 0 0 0 0 0 0 0 0, and here -2 0 0 0 0 0 0 0. Okay, and also similarly 0 0, all zeros, and this place 0 0, and here also 0 0 0, and here 0 -2 0 0 0 0 0 0, this set, and also 0 0 0, all zeros 0 0 0 0 0 0 0 0, and here -2 0 0 0, and 0 0 0 0, and here 0 0 0 0, and here 0 0 0 0, and here 0, here -2 and 0 0 0. Okay, span by this set range base. Okay, clearly we see that this element, suppose this is my b, here my m1, and this is m2, this is m3, this is m4, and this is M5 and this is M6 and this is M7 and this is M8. Okay, this set M1 to M8 is a Li, linearly independent. So this is a form a basis for range set of TA. Okay, so dimension of TA of range set of TA equal to 8. Okay, answer is 8. So answer of the question is 8. Okay, now summarize this question. We already know that if E1 E2 dot En is a basis of V on a linear operator, then range set is spanned by T of E1, T of E2 dot T of En. Okay, this is a famous result. Okay, now we find the dimension of range base of T, then find the basis of T. Okay, so this is a spanning set, and we also know that every spanning set has a contain a basis. Okay, so we can find only here which set is form a Li, which subset of spanning set is Li. Okay, so this is a form a basis of the range set of T. Okay, so here we already know that the standard basis of M4R, this is a 1 0 0 0 0 0 1 0 0. Okay, this is a basis. Okay, we find range of the basis element. This is, so we easily see that when here non-zero, then here 2. Okay, so similarly they find all the range of the image of the basis element of M4R. Okay, and by this result this image set of the basis element span the whole of the linear transformation, range of the linear transformation. So this is spanned by the range set of the linear transformation. Okay, so next we find the which subset is Li. We clearly see that M1, M2, M3, M4, M5, M6, M7, M8 is Li set. Okay, and this is also spanned by the range space of the linear transformation. So dimension of the range of the T is 8, because number of basis element is a dimension, so the dimension is 8. Okay, so answer of the question is 8. Okay, thank you.